The diagram shows a sketch of the graph y equals f of x. The graph has a maximum point at 1, 3 and intersects the x-axis at the points minus 2, 0 and 4, 0. Sketch the graph of y equals f of 2x, indicating the coordinates of the stationary point and the coordinates of the points of intersection of the graph with the x-axis. B. Sketch the graph of y equals fx minus 5, indicating the coordinates of the stationary point. Given that f is a quadratic function, use the graph you have drawn in part 1 to write down the number of real roots of the equation. Okay, so I've got the question summarized here. So here's our curve, which we'll copy and paste below us, and we now need to sketch f of 2x. Let's have a go at that first, indicating the stationary point and the roots. So part A then. Okay, let's have a look at this then. Here's f of x, which we've got conveniently printed here. So f of 2x then. So this is f of x. So when, basically here, when x was 4, y was 0. So to get 4 here, we'd need an x of 2. So rather than being at 4, 0, 2, 0 will be the coordinate, won't it? Because when you put in 2 here, you'll get f of 4, which is 0. So that coordinate, in effect, moves in, compresses inwards, doesn't it? So let's put that down then. So that's a point here, and that would be 2, 0. Okay, now as far as this one's concerned, if we put x as minus 1 in, we'll get f of minus 2, 0. That's that coordinate there, and that squeezes in as well. So this is minus 1, 0 now. So basically what's happening, and this 1, 3, when x is 1, so to get 1 we need x as half. So this point moves in here, but the height is still 3, of course, isn't it? So now we can do the sketch of the curve then. Let's have a go at that. Let's just get rid of this as best we can, our original function. Now that we've got our turning points here. Okay, oops, let's get the y-axis back in, that helps. There, and I'll just try my best to get rid of this here. And that one there, and that point there. And it's going to be a half and 3 we said, didn't we? So, okay, we've got this coordinate here, which is a half and 3. So when we put half in here, we get f of 1, which is 3. So it's like it's squeezed up, isn't it? So this curve now behaves in the same manner. It just goes up, comes up and down, so to speak. But it's compressed, it's squeezed up, isn't it? By a factor of 2. There it is there. So this is y equals f of 2 of x. We've indicated the roots, the places where it crosses the x-axis, and we've indicated the stationary point. Now we need to sketch f of x minus 5. So let's get back our original function then. Here it is here. And we'll move that down to here to do part B. So we now need to turn our attention to f of x minus 5. Basically, we're going to shift these points down minus by a value of minus 5, aren't we? So all these y values will be 5 less than what they are at the moment. So this will move. Here the 1, 3 will move down to the coordinate 1, minus 2. So that would be 1, minus 2. And we'll get the same curve, but it's just like shifted down by 5 units in the vertical direction, isn't it? So y equals fx minus 5. So it's shifted down vertically a distance of 5 units from where it was before. And there's the turning point here now, 1, minus 2. Okay, that's part B. Now part 1, and the stationary point was there. Given f is a quadratic, use the graph in 1 to write down the real roots of fx minus 5 equals 0. So I've just drawn that, fx minus 5. The real roots of this, fx minus 5 then, which is what this is, when does that equal 0? It never equals 0. So part 2, no roots, no root values.